In a typical reactor, you have a number of sensors that go into the reactor. And at the same time, you have actuators that carry out specific action, right? That is a reactor like you will see on Monday, your crack on Monday. You have a number of sensors that go into the reactor, then a number of actuators that act on it. And I would like you to pay specific attention to this slide because that enables you to understand how control is carried out. And also feel free to interrupt if you don't understand. All right. Let's take again this reactor that we just gone through that has sensor for pH. It has sensor for temperature. It has sensor for oxygen concentration. Okay. The idea is these sensors have to transmit the state of those parameters. In other words, the temperature sensor will have to transmit the value of temperature to a unit that is called the controller or the control unit. The control unit will have to take an action based on the value received, whether to heat up or to cool down the system. That is referred to as a feedback control system. Now, let me take a typical case here. If you take the case of temperature that we have here, you have a temperature sensor that is somewhere here in the reactor. Let me see if I can put the laser pointer for you to follow me. Okay, you have a typical temperature sensor that is here. What a temperature sensor does is that it transmits the value of the temperature in the reactor, that is the value, the temperature value from the broth to this unit, the green unit, which is a controlling unit. The control unit will compare, listen everyone, it will compare the red value, the value received with what's supposed to be, that is the set point value. I repeat, the sense value sent by this sensor is compared with the set point value, SET, set point value. Two things, sense value and set point value. The set point value is a value that you want the reactor to maintain. Now, if the value is different from if the sense value is different from the set point value, the controller will decide whether to heat up or to cool down the system. If you look at it, the green arrow, the green stream that leaves the control unit goes back to this entire block. The block will decide whether to allow a cool water to go through the water jacket or a hot water to go through the jacket. That is, depending on the temperature value right here, the control unit will decide whether should we heat up or should we cool down. The idea is, the unit want to adjust the temperature in such a way that the prevailing temperature of the reactor corresponds exactly to the set point value. Now, let me recap again. You have the sensed value, the value read from the broth that goes to the control unit. The control unit compare the sensed value with the set point value. The set point value is the optimum value that you want to maintain on the reactor. Based on the deviation obtained, the controller will decide, should we heat up the system or should we cool down the system in order to adjust the temperature to the level, to the set point value. And in so doing, it decides whether the solution to go through the water jacket is going to be a hot solution or a cool solution. Now, let me take another feedback control loop that you have here. That one is referred to as the pH control loop. What I've described now is temperature control loop. Loop is LOOP. Okay, what I described is temperature control loop. I'm going to take another unit. That will be the pH control loop. How does the reactor adjust the pH value within the reactor, within the broth? Again, you're going to have a pH sensor that is in direct contact with the broth. The pH sensors transmit the sensed pH value to the controller again. The controller will compare the sense value with the set point value. Set point value is a value that you want to maintain on the reactor. That is the optimum value for growth or the optimum value for product formation. The sense value is again compared with the set point value. and the system decide, should we add acid or base into the reactor in order to adjust the pH to the set point value? Let me repeat. The pH probe will measure the pH value from the broth. Of course, we learned from the previous classes that the pH doesn't remain constant due to the metabolic activity of the cells. The pH probe will now measure the pH value from the broth, transmit the signal to the control unit, which is here in green. The sense value will be compared with the set point value, and the action to be carried out will depend on the deviation, whether it is below the set point value. Of course, if the pH sense is below the set point value, this unit is going to instruct the actuator, that is the peristaltic pump that carries acid and base here, add an amount of a base to raise the pH. However, if the sense value is above the set point value, the instruction being sent from this unit to the actuator will be to add some drop of acid solution into the reactor in order to adjust the pH. The unit is like the brain. It decides on what to do in order to maintain the optimum parameter. You're going to recollect that as part of the feature of the reactor, we said the reactor has to be able to maintain the control environment optimally. And this is how it does it, using this kind of feedback control mechanism. I've explained the temperature control mechanism. I've explained the pH control mechanism. And virtually all parameters, well, most parameters are controlled using this feedback mechanism, which the sensor sense. The signal is transmitted to the control unit. The control unit decides whether to decide on the appropriate action to be taken in order to adjust the parameter to the set point value. I repeat, the sensors will transmit the state of the reactor or the sense value into the control unit. The control unit will compare the sense value with the set point value and decide on the appropriate action to be taken in order to adjust the parameter in the reactor to the set point value. In other words, if I ask you in your exam to explain a little bit how the feedback control mechanism works, the reactor, you should be able to explain that to me, right? And obviously, you're going to have it in one of your assessment. Yeah, the pH drift, like a student has asked, the pH drift can be caused with metabolic activity, right? The metabolic activity will affect the pH, the drift of the pH, and that pH has to be brought back to the set point value by this mechanism I've just explained here. All right, okay, let's summarize a little bit what I've said using this small diagram. In a typical reactor, you have a process. What causes the parameter to change are called disturbance. I repeat, the disturbance will be what will cause the parameter to change. For example, in the case of the pH will drift due to metabolic activity or due to the nutrient being, due to metabolic activity. And that drift, that metabolic activity becomes a disturbance in the process because it disturbs the pH value. They refer to it as a disturbance. Now, the value of the pH in the reactor will be measured and sent to the controller, which you have it down here. The controller will compare the sense value with the set point value. And based on the deviation found, the controller will issue an action back to the reactor in order to adjust the process. Let me recap again. This diagram summarizes the control loop. You have a process, you have a disturbance. In the case of pH, that will be metabolic activity. In the case of temperature, that could be metabolic activity or agitation. Right? Disturbance is any factor that will cause the parameter to drift away. That's referred to as a disturbance. Right? The disturbance is what will cause the parameter to drift away. Now, in this scenario, like I said, the disturbance will cause the parameter to drift away, and the sense value is measured. The controller receives the sense value, it compares with the set point value, and it adjusts the process accordingly based on the error, the deviation obtained, right? This simple diagram explains a little bit to you what the control loop is about. Now, just to put in theory what I've explained, we said a controller seeks to maintain the measured process variable, that is a PV. The measured process variable is what you have measured from the reactor at a set point value. The set point value is what you want the reactor to maintain. For example, if you have discovered that for your cell to produce your product optimally, they require 37 degrees of temperature. Therefore, your set point value will be 37 degrees. If you realize that yeast require 25 degrees to grow optimally, your set point value will be 25 degrees. Now, they say the controller seeks to maintain the measured process variable PV at a set point value in spite of the disturbance. The disturbance are any factor that will cause the parameter to drift away from the current value, right? Disturbance is in the case of the disturbance, for example, the case of substrate concentration will be the metabolic activity leading to the cell using the substrate, right? That will cause the nutrient concentration to change. That will become a disturbance. Now, just to summarize the key element involved in the control loop, you have a sensor, you have a controller, you have an actuator. Please underline these three elements. A sensor, a controller, then an actuator. These are the three components that get involved in the control loop. A sensor, a controller, and an actuator. The key elements involved are the sensor, the controller, and actuator. You have to understand those three elements, how they function in harmony in order to establish, to maintain your reactor optimally controlled. Now, let's look a little bit again further. I'm just trying to drill down a little bit to tell you much more things that takes place in the control loop. We said the control algorithm. Well, what is an algorithm, class? What's an algorithm? Okay, an algorithm is a step-by-step to follow to solve a problem. Okay, an algorithm is the different steps you need to follow to solve a problem. Now, the control algorithm performs the following task in the control loop. It will read the appropriate sensors within the reactor. It compares the sense values with the desired set point. The desired set point, those values that you have found to be optimum to your process. Third, it actuates pumps, valves, or motors towards reducing the deviation back to zero. Then it goes back to step one. That's what we refer to it as a loop, something that goes in a circular fashion continuously. Let me repeat. First steps. That is the software. What the software does is it reads the appropriate sensors within the reactor. It compares the sense value, that is the value it has read, with the desired set point. The set point are those that you have found to be suitable for the process. After comparing, we'll decide on the action to take. It decides the right pumps, valves, or motor that need to be actuated so that the deviation obtained from the comparing is reduced to zero. That is, there will be no deviation again. That is, it wants the sense value to be equal to the set point value. Therefore, the deviation will be zero. Does it make sense to everyone, class? It wants the sense value and the set point value to be the same. That's why we said it has to actuate the pump. If there's a need to heat up, it will heat up. There's a need to cool down, it will cool down. If there's a need to add acid, it will add acid. They need to add a base, it will add a base. There's a need to add an antiform, it will add antiform. If there's a need to increase the agitations, the motor will actuate faster. And all these actions are taken towards ensuring that the sense value corresponds to the set point values. Then, after that, it goes back again and repeat. That is constantly throughout the process. If you are running a reactor for approximately a week, every millisecond, not second, every millisecond, it will be performing this task. Every millisecond it will perform this control loop. Millisecond, not even second, because it has to ensure that the process does not deviate, regardless of the condition, does not deviate significantly from the set point values. All right, this further illustrates what I've said, just a typical control loop. Class, I won't give you too much information, but what I'll do is I'll allow you to take the remaining minute to reflect on this section. I will rather let you reflect on what I've explained to you, the control loop. Reflect on the control loop now, and also at 11:45. I would like you to use the 11:25 time to further get acquainted with the control loop. Okay, you're going to have your prep on Monday will focus on the reactor, right? Use the 11:25 time to further understand the explanation that are given to you, and as well as the material that is in model environment. Okay, that's what I'm going to leave it to you to do for 11:25. That is, you're going to engage yourself with the resources in the model environment with respect to the control system of the reactor. Any question before I release you at this point? Class,
yes,